Tēnā koutou, katoa, welcome back. So we're going to move on now to the respiratory system and talk about the exchange of gases. So the goals for us moving through here, to name and describe the anatomy of the respiratory system, to describe the physiology or the functions of the respiratory system, and also understand some common conditions associated with it. Okay, so just like we did with the cardiovascular system. All right, respiration, what is it? Essentially, it allows one to obtain oxygen and eliminate carbon dioxide. So oxygen is important in terms of fueling our body, and carbon dioxide is waste that we need to get rid of. Build-up of it in our body becomes toxic if we aren't able to do this. Okay, consists of two phases, inspiration and expiration. So inspiration, process of taking the air in, into the lungs and then getting the oxygen out of it. Expiration, the process of blowing out air and taking the waste and the carbon dioxide out. Okay. The system itself, you look at that and go, kind of complicated. Not all those terms there you will need to understand. Most people know that they have a couple of lungs, which is great. We'll talk specifically about, the passageway and each part of this system as you move through from the nose and the air outside all the way down to the alveoli and the lungs have an important function. So, for example, and we'll kind of talk about it on the next slide a little bit as well. This kind of breaks it down. So the nose and the mouth are a passageway. Nose really important in terms of making sure air is filtered and moist. Moving on to the next bit down there, the epiglottis, so it covers the larynx during swallowing, so it obviously stops our food and water from going into the lungs because we don't want that fluid in there. The lungs themselves, we've got intercostal muscles that help physically expand our kind of thorax and our rib cage to help in inspiring or drawing air into the lungs. The diaphragm as well, which is a muscle there that also helps it. On the other side there, the nasal cavity, the throat or the pharynx, so the common passageway, the larynx or the voice box, trachea or the windpipe, all important to get that air or the oxygen down there. So like I said, there's filtering jobs, there's obviously we've got the epiglottis there, we've got the trachea or the windpipe that's got the cartilage around it to help keep it open all the time so it doesn't fold in, because it's kind of important that it doesn't. And then we move down into the bronchi, so it breaks into the left and the right side, breaks into those bronchi, which are just the tubes that are on the left and the right there. Then it breaks down into smaller tubes called bronchioles that aren't kind of labelled there, but it's the secondary branching. And then it moves down to the alveoli, which are at the end of the bronchioles, and that's the place where that gas exchange happens. It's so important for us. Okay, so the table here kind of breaks that down in a little bit more of a structure from inside to out. So the nasal cavity warms, moistens and filters air as it is inhaled. Okay, so it's really important for that to happen for us to be able to use that and to have as little foreign particles traveling through there as possible, because it's the lungs and the alveoli are a really important link between the air outside or the world outside and what's going on inside our bodies. Passageway, the pharynx or the throat, leads to the trachea. So the voice box where the vocal cords are located is called the larynx. So pharynx and larynx. Trachea or the windpipe, remember we talked about that being surrounded in cartilage, so you can so it protects the airway, because without that we can't get oxygen to our cells and we can't be alive. So that's pretty important. lined with fine hairs called cilia, which filter air before it reaches the lungs. And it also helps us move mucus when we're sick as well. So getting stuff out of the lungs. So if you're not well, the stuff you cough up, that starts kind of moving up that passageway via the cilia. The bronchi, so two branches at the end of the trachea that lead to a lung. Like I said, the bronchioles, they're the smaller branches, the kind of secondary branches, and then ultimately they move to the alveoli, which is the, in terms of terminology, functional respiratory unit where the gas exchange happens. So where we actually take the oxygen from outside in the air and take it into our blood, so then we can transport it back to the heart and then out to the body. Okay, so like it ties in, like I said, with the cardiovascular system. They've both got really important roles to play together. So when we're talking about the respiratory system, components, upper respiratory tract. So if you've got an upper respiratory infection, it will be related to one of these things. Okay, so like we've talked about before, I'm not going to go kind of over those again, but all of those parts constitute the upper respiratory tract. Any issues around the sinuses, the nasal cavity, larynx, epiglottis, trachea, any of those things are considered the upper respiratory tract. Function, passageway for respiration, receptors for smell. We talked about filtration a little bit there, so to filter larger foreign material, moistens and warms the air, and resonates chambers for voice. Moistening and warming the air, really important again, because remember it's that link between the outside world and the inside. So if the air coming in is either really warm or really cold, then we need to kind of bring it back to the temperature that's going to be appropriate for our body to use. So again, we're always looking at that, the word that comes up over and over again in anatomy physiology is homeostasis. Our body likes to have everything at the right temperature so that it functions most effectively. Okay, lower respiratory tract, from the trachea, left and right bronchus, bronchioles, clusters of alveoli. Okay, those are the things that we have there. In terms of function, so larynx maintains the open airway, routes food and air appropriately. So obviously, like I said, we need to split that. So we've got a common passage in the upper respiratory tract where food, air and water and liquid all go down the same spot. The epiglottis is the bit that closes over the airway to stop your food and drink going where it shouldn't into the lungs. And as we said, the assist in sound production. The trachea transports air to and from the lungs. The bronchi takes it further into the lungs. And then they transport it to the alveoli where gas exchange happens. Okay? All pretty straightforward. When we look at alveoli, people will talk about them looking like little bunches of grapes. Essentially what they do is they are surrounded in those capillaries. So like we talked about when we're talking about the cardiovascular system and the tissues that are 1 cell thick that allow that gas exchange. So the gas that we've got in the alveoli itself from the air outside of our bodies, we can then diffuse it or transport it across those membranes in the or across those cells in the capillaries to be then transported by the hemoglobin and taken off back to the heart to then be pumped around the body. Okay, so they are, again, those capillary beds are really important because that's where it happens. And again, we need all of those stages of filtration to get down to there, so we get all of the particles that we don't want down there interfering in that gas exchange out, and down, the alveoli themselves, the smallest functional units so that it allows these capillaries to do their work and to do their thing. Okay, the respiratory cycle. So the muscles that help, there's kind of two muscles there that'll help. The intercostal muscles, so that just means the costals refer to the ribs, so that's the muscles between the ribs, and the diaphragm, which sits underneath the rib cage, kind of underneath the lungs. So what happens is, in our relaxed state, the muscles are relaxed. Okay, when we, in terms of inspiration, when we breathe in, if you take a deep breath in, what will happen is the shape of the diaphragm will flatten out, so it'll go from something that looks like that to something that looks like that, so it kind of pulls down that way and flattens out. And the ribs move upward and outwards due to the contraction of the intercostal muscles. So both of those things will expand the volume of the thoracic cavity, therefore changing the pressure. So pressure and volume have an inverse reaction, so there's less pressure now than there is outside, so it forces air to rush in. Okay, on the converse side, expiration, diaphragm and intercostals relax, so the diaphragm comes back up, the ribs and stuff come back down, decreases the volume inside that thoracic cavity, therefore increasing the pressure, because again we've got that inverse relationship called Boyle's law. You don't need to remember that, but just for those that want to know. So the increase in pressure means that forces air from here, so it's now at a higher pressure than what's outside, so it forces it back out. Okay, so that's an important mechanical way that your body will actually encourage air in and encourage air out of the lungs as well. Okay, if you were to read anatomy and physiology textbooks, it will talk about respiration in 4 stages. Okay, breathing, so breathing in and out like we talked about, called ventilation, getting oxygen into the lungs and carbon dioxide out. So that's just what happens at the level of the lungs. External respiration is the gas exchange. So respiration is that gas exchange. So it's between the air and the blood. Okay, so at the alveoli, external respiration happens where we get the oxygen from our lungs and the bronchi into our bloodstream. Okay, internal respiration happens at the other end. So when that it happens in the capillaries at the tissues, so once it's been back to the heart and pumped around the body, that internal respiration is what happens at the tissues or the cells. So when the blood has reached its destination, the oxygen gets transported or diffused from the blood into the tissues, into the cells where it's needed. The carbon dioxide gets transported from the tissues into the blood and then transported on the way out. So external respiration happens at the alveoli. Internal respiration happens at the cells or at the tissues. Okay? And cellular respiration happens inside the cells to produce oxygen, produce energy or ATP. So like we talked about last week when we were talking about the function of the cells, that respiration happens related to the mitochondria. So that is where that process happens inside the cell. So it's the 4 different kind of stages of respiration. So it's not as simple as just what happens at the lungs. There's a process to get that oxygen from the air all the way down to the cells where it's needed, and to get the carbon dioxide from the cells all the way out of our body. Okay, to look at conditions related to the respiratory system now. So we're going to go over a couple briefly that you may commonly come across in your practice. So asthma being the most, probably the most common one, and all that is a severe allergic reaction characterized by constriction of the bronchioles. So that obviously makes it really hard to be able to breathe normally, to breathe naturally. anybody that's had any experience with asthma will know that, it's obviously not a very pleasant experience. So any discomfort you have with breathing can really get people in a particularly agitated and panic state, because it's vital to our survival. Bronchitis differs a little bit in its inflammation of the lining of the bronchioles. So again, the tissue themselves become red and inflamed, probably cause and create a little bit of mucus around that. Emphysema, a condition which the alveoli deteriorate, so the alveoli themselves, causing the lungs to become less elastic. So it's really important that the lungs are elastic to allow oxygen to come in, for them to expand, and for them to contract to then increase that pressure and force the oxygen out again. So if they lose the ability to do that, that can become a real issue. Pneumonia, which is caused by bacteria, a condition which alveoli become filled with fluid. Obviously that makes it really hard for your body to follow through and do that gas exchange thing, that external respiration that we talked about, and transport the oxygen and get the oxygen out to your tissues where it's needed. So obviously that's a really serious kind of condition. Lung cancer being irregular growth of tumour within the tissue. So not very much fun either. The last slide shows you just a little bit of detail about, so I don't really expect you to fully understand what's going on here and remember or understand all the terms, but it's just to be able to conceptualize how some of those conditions might affect a person's normal ability. So if you have a look at that line, the tidal volume is the normal amount of oxygen or air you breathe in and out within your normal respiratory cycle. The kind of the top and the bottom of the graph give us the where the green line goes up to and down to, where are your inspiratory and expiratory reserves. So if you were to breathe in as much as you can, that's how much oxygen you could get in. If you could breathe out physically as much as you can, obviously we don't expel all the air out of our lungs because we still need enough in there for them not to collapse. So you'll see that expiratory reserve doesn't go all the way down to empty, down to zero. We've still got a litre or so in terms of volume in our lungs, and that bit at the bottom there is called residual value. You can see the dotted graph, the orange one there, shows what happens. So when someone had emphysema, so you could see any of those conditions are really going to impact any one of those portions of how our body's able to function, and therefore have a really negative impact on our health. Okay, so I'm going to leave it there for this lecture. And so again, there'll be an activity related to this, there'll be a Kahoot related to this, and then 2 more short videos looking specifically about asthma as a condition in a little bit more detail, and COPD. So we'll catch you all on the flip side.